Okay, so I finally got a few free minutes to start tackling number 19 in the homework. Several people wanted a little bit of exposition on 19. I think I'll only do part A, and I'll leave part B to you. Even though part B is the hard part, I think by the time you've seen the end of this, you should have it. Okay, so in 19, we're given a map from the rationals with ordinary multiplication into the rationals with some unknown operation. And we're told what the map is. We're told that the map is phi of x goes to 3x plus 1. And you're told to assume that it's 1-to-1 and onto. It actually wouldn't be hard to show that it's 1-to-1 and onto. So we want to define star so that phi is an isomorphism. So we can try what I did last time, and it turns out to be slightly harder to see. But we could look at least and see what phi does. So phi of 10, for instance, goes to, I have 3x plus 1 instead of 3x minus 1. Goes to 3 times 10 minus 1, which is 29. Or phi of something else with good factors. How about 12 is equal to 3 times 12 minus 1, which is 36 minus 1 is 35. So that's what phi looks like. Now let's consider what star will have to look like if it's going to make sense. So we know phi of 10, so let's look at something like 2 times 5. Well, that's of course 10, so phi of 10 we already know is 29. But if this is going to be an isomorphism, this has to be phi of 2 star phi of 5. Well, that turns out to be, well, phi of 2, we know phi of 2 is going to be 6 minus 1 is 5. Phi of 5 is going to be 15 minus 1 is 14. Now we can try the operations that we know already on the rationals. For instance, we can try 5 times 14 to see if it's actually just ordinary multiplication. Well, 5 times 14 is 70, right? Anyway, it's not 29. It doesn't seem very close to 29. We can also try 5 plus 14. That's 16. Geez, that doesn't seem very close to 29 either. It doesn't seem like there's a nice way to adjust it. So those definitely aren't the operations we're talking about for star to make phi an isomorphism. So I'm going to notice something else. Suppose I just ended up with m star n, and I knew what m star n was in abstract terms. In terms of m, if I knew m star n in terms of m and n in the ordinary operations on the rationals. So I'm going to do a little scratch work off to the side, and I'm going to notice that if I take phi of something like let's say phi of m plus 1 over 3, then that will be equal to 3 times m plus 1 over 3, which is, and then minus 1, which is m plus 1 minus 1, which is m. So notice if I take phi of something in this form, I just get m. So I'm going to consider phi of m plus 1 over 3 times n plus 1 over 3. Well, if this is an isomorphism, that should be phi of m plus 1 over 3 starred with phi of, I'm going to have to move this over, phi of n plus 1 over 3, which, as I've shown over here in the scratch work, is just m star n. But the benefit of doing it this way is I can also go the other way. I know this has to be 3 times m plus 1 over 3 times n plus 1 over 3 minus 1. And that'll be equal to m star n. So if I do this algebra out, and I'll let you do the algebra, but I'll just tell you what it is since I worked it out earlier. It's 1/3 mn plus m plus n minus 2. M star n. And I'm going to conjecture, or I'm going to conjecture that m star n equal to 1/3 mn plus m plus n minus 2 will make phi an isomorphism. So let's just check it with the one number we checked already. Let's do phi of 10, which is 29, which is also phi of 2 times 5, which is phi of 2 star phi of 5. Let's see, phi of 2 is 3 times 2 minus 1, which is 5. Phi of 5 is 14. I think I already did that, right? And then, according to our definition of star, right here, this will be 1/3 m times n, so 5 times 14 plus 5 plus 14 minus 2, which is, let's see, 1/3 times 50, 70. 70 plus 5 is 75. 89. Oops, let's see. 70 plus 5 plus 14 minus 2 is 84. 89 minus 2, which is 87. Oops, I did something wrong here. Let me pause for an instant to see what I did wrong. Ah, no mistake. I actually just didn't recognize that 3 times 29 is 87. So that is 29. So it definitely works in that case. Now, it might not be easy to see what the identity element is, but let me suggest a way of doing this. Let's consider phi of 10 again. That's also phi of 10 times 1, and it still should be 29. And this should be phi of 10 starred with phi of 1, which will be, well, 29 starred with phi of 1 is 3 minus 1, so 2. And that should still equal 29, so I claim this shows that 2 is the identity of star as defined. And let's just really quickly check that if 10 star 2, 29 star 2 is still 29. And so that'll be, according to our definition, 1/3. 2 times 29 plus 29 plus 2 minus 2. And you can see the plus 2 and minus 2 cancel, and we've got 1, 2, 3 copies of 29, so there'll be 3 times 29 times a third, so it'll be 29. Okay, so that ought to get you started, and I will see you all on Monday.